Hi, I'm Clarisse Abalos, and I'll be talking about using OpenStreetMap to download labeled satellite imagery for training machine learning models. So one of the biggest challenges to developing an AI ML model is gathering enough training data. And one of the biggest challenges for OpenStreetMap is keeping the map complete and up to date. So there's this shared interest in creating and maintaining labeled data. And both of them can benefit if you're able to create training data from the map that's been updated by the community of mappers and validators. And that training data can be used to improve the model inference that can be used to direct mapping and tell people where the map needs to be updated. So our friends in Heidelberg have created this tool called OSM to label, which allows you to create a config, which will tell you, which will indicate which OpenStreetMap keys and values map to your labels that you're using for your model. And it'll create an overpass query to download those features and tile imagery at a given resolution with those labels. And then it marries that with the satellite image that's downloaded in an MS Coco JSON file, which is used to train your model. Problems you'll run into with this is there's still going to be issues that require review and adjustment, right? You could have missing or partial imagery. You could have the feature totally obscured by clouds. There could be a shift from where it was mapped and where the image is showing the feature. The area could be completely annotated and missing some, or incorrectly annotated. So for that, there's another free and open source tool called Computer Vision Annotation Tool, which is also called CVAT, which allows your team to collaboratively review and annotate the images. So you could upload the images and annotations, like the ones that were generated with OSM to label, and then go through each of those images with your team and add anything that may be missing or edited. So here you'll see there's the apron that's labeled, but it's missing the runway label, which you can just add, and then your team will go through all this together, and you can export the completed task data set as a COCO or your file or a variety of formats that you might need for your model. Now, let's say you have a really large training data set and you want to get a better idea of what kind of imagery you have in there. I found that this other free and open source tool called 51 was very helpful for visualizing and filtering through that data set. So they have this feature that allows you to sort by similarity, which uses image embeddings to look for similar images. And that's really helpful because you could target which ones are cloudy, which ones are missing or partial. Or if you're trying to be like more specific with your classification, you could say, you know, I want more imagery that has unpaved runways versus paved runways. And you could take this data set that you're managing in 51 and with an integration, even create CVAT jobs for your team to then go in and, you know, use this, edit this training data. And if you're reviewing like the model outputs on the imagery, you could also use this feature to do some hard negative mining. So if your model keeps saying that it's a feature incorrectly, then you can look for that feature in this imagery to make sure to say, you know, that's not what we're looking for. So if you're interested in some foundational data sets that Maxar provides the humanitarian community in times of crisis to help with response efforts, you can check out the Open Data Program. And if you're interested in labeled training data and algorithms, check out SpaceNet. And be sure to talk to Desiree Petrie, who's sitting right here. And this is me. So thanks for listening.